for circles, right, you need to know a few important locations. What are the important locations? Number one, you need to know that this is called the center. That's number one. Number two, you need to know that anywhere from the center to the circumference is called your radius. Now, why is radius very important? Radius is very important because wherever you see radius, radius is always the same. They're always the same length. So when you know it's the same length, you need to draw tiny lines. So this is my lingo, okay? So going forward in future, if I say, guys, you see radius, what must you do? You must tell me, oh, Miss Lin, if you see radius, it means that you need to draw your tiny lines. Why you need to draw tiny lines? I'm going to show you guys why. Because right here, guys, listen first, okay? I'll give you all time to copy. So right now, can you see that I have this thing and I have this thing? The moment I draw tiny lines, and when I draw a line, what do you notice? Because this is a length and this is a length, right? They are radius. So what do you notice? What happens? The moment I draw tiny lines. Yeah, what happens? What appears? What appears?
What is that? Triangle.
What appears?
Right angle. Right angle, not necessary. What appears? What kind of triangle? I need to be more specific. Yes. Triangle. So that's why this is so important, because an isosceles triangle will appear. And this will help you with a lot of information. So isosceles means this angle here and this angle here are the same. Understand? Okay, now you can make your notes. Okay. This center is circumference. This circumference location is very important. Later we'll go more in depth. Okay, so today we'll focus a lot on angles. So we're going to learn a few properties. The first property I'm going to do is this one, because this one is what you are familiar with for your emath. We have the center, the same thing. And by now you all know it's radius, right? So this is radius. Radius is always from the center to the circumference. So remember I told you guys, what is the best friend of radius?
Tangent.
Very good, remember. So the best friend of radius is tangent. So tangent means the line that is just nice touching the curve at one point. So that's what tangent means, okay? So this line is called tangent. And what's the relationship between a radius and a tangent?
Perpendicular, 90 degrees.
Perpendicular is 90 degrees. So this is the first property you all need to know. Okay, you all can do that. You write that down. This property is called tangent is perpendicular to radius. This is the property that you need to memorize when you are using this property. Okay, I'll teach you all one more, okay? The next property. Property number 1. Next, this is property number 2. So what is property number 2? Okay, guys, later you all listen. So right now, this is one point here and another point here. I'll treat this as this is the start and this is the end, okay? So when we start, right? Start. Can you see where I'm touching? I'm touching away. Circumference. I repeat again. I go a start. I touch the circumference. And then I go back to the end, right? So this is one of the angle. Okay, so we have start, touch circumference, and then we have an end. Now, next is also the same thing. We have a start, we touch the another circumference, and then we go back to the end. So can you see that? So usually I call this as a bow tie. So what is the strategy I call this as? Like a bow tie. Okay, when it's a bow tie, take note that the top of the bow tie will be the same and the bottom of the bow tie will be the same. And you need to be very careful. Your bow tie, the four corners of your bow tie must all touch the, yes, all corners must touch circumference. And this is the part always students will be very confused. Later, I'll go in depth in telling you why some properties is more confusing than the other property. Okay, just remember, location is very important. When I say location, we are always locating where the circumference is. Circumference, 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 circumference. Now you can make your notes. And how to use this? This just means, right, if here is 20 degrees, means this one is also
20 degrees.
20 degrees. And what is the reasoning of this? The reasoning that you need to memorize is called angles in the same segment. All right, you can make notes. So we already learned this, right? The second one is this. So the next easy one is draw a circle. Now, this one you need to be very careful, okay? Why do I say this is very careful? How many sides are these? How many sides do you all see? So this is like a cyclic chord. Cyclic means in a circle. Chord means quadrilateral. You all know four-sided figure is quadrilateral, right? Cyclic quadrilateral. And what do you notice about the quadrilateral? 1, 2, 3, 4. There are 4, right? Four-sided. And all these 4 points is at where? On where? Must be circumference. Now, when they are in the circumference, we know that this person plus this person is 180. And this person plus this person will be 180 degrees. Get it? So this property you need to memorize, and it's called angles in opposite segment. And that is property number 3. Next, property number 4. So property number 4 is same thing right now, but it's a semicircle. We kind of did it a little bit in emath already. So this is a center, right? So semicircle involves a diameter. So guys, please take note. A diameter cuts from one circumference to another circumference. This is called a diameter, and it must pass through center. Because only when it passes through center, then you can call it as a diameter. Not sure if you all still remember. So for Corinne, because she wasn't here last lesson. Okay, so can you see here? Can you see that this one goes from one end to the other end? Does it pass through center?
No.
No, it's called a chord. Understand? It's called a chord. Give some bangs.
And guys, back, man. He's back.
Hey!
Oh no, he's back.
Oh, never
Oh,
mind.
never mind.
I don't know how to draw a hoodie. Draw
That's-
string, draw string.
That's cute. Spectacles.
The penguin is very hard to draw. It's very complicated.
It's so cute.
Tired
Oh,
eyes.
Oh, that's
Wah,
lovely.
dang, dang.
Oh, Mason's
Mm.
drawing was already cute.
Dun, ching, 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 boing, boing.
Hey, the
Ding, ding,
I've
ding,
still got
ding, ding,
smiley
ding.
face one, yeah.
Ah, who does it look like? Boing, boing. You guys know who it is. Ching, 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 ching.
Like the glasses.
yeah.
Does look
Nothing
like.
goes through the glasses lens. Damn.
Shung, 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 shung.
Okay, that is completely no more circle already.
Is that so small world that we have a student that has bangs? Okay. Let's simplify everything. Ding, ding, ding. Okay. Ding, ding. All right. So this is chord, okay? So another thing you need to know, since we're already at chord, there's one more you need to know. Is that right now it's the same thing. I have a center, right? So I have like that. This is like a pizza already, correct? So this pizza, this is called radius. Radius, where it has two radius. That means that this thingy here is no longer called, oh, this is called a segment, by the way. The bangs is called a segment. And this is called a sector. Got it? But right now, this one here is called a diameter, and this is a semicircle. Clear so far? Understand? So when it's a diameter, can you see I go here to here? And I go from here to here, right? So this thingy, always remember that if it's a semicircle, cuts through the diameter, this person is always a right angle triangle. Meaning they can test you things like A, B, C. They say, hey, prove that angle ABC is 90 degrees. Or in exam, they can say that, hey, prove that triangle ABC is a right angle triangle. Red means right angle triangle. Or they can test you things like, prove that AC is a diameter of the circle. Clear so far? These are the three question types they can test you, and you know that whenever they ask you this, very high chance I'll be using this property. And this property is called angles in a semicircle property. So far, so good?
Okay.
Now you can make your notes. Guys, even though this was quite a joke, but you must still put in, okay? Segment, sector. A lot of students always forget.
Oh my god, they forgot.
Okay, just now was number 5, is it?
4.
So now it's number 5.
4, yes.
Okay, so number 5, let's go. Number 5 is the most tricky one. I need your full attention. So everybody, don't do anything. Just listen. Technically, I should draw all of them nicely in one line.
Is it satisfying to look at circles?
What?
But too much circles creeps me out.
Why is trypophobia?
Yeah, I have.
She's scared of strawberry hole. She told us before.
Yeah, oh my god, guys, this is recording. Don't say out. Don't say out my fears.
Okay.
Right now, over here, the next property, right, that you need to memorize is called angles. This one is very long, but it's not that difficult. Angles at center. Why do I leave it last? Later you all will know. It's actually equal to 2 times angle at center is equal to 2 times angle at circumference. Now, do you all remember just now, whatever I went through was all only on circumference? But right now, we have a mixture of center
And the circumference.
and the circumference. Okay, we'll go more in depth in this. So what is center? Center, it's here, 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 correct? These are all the center. Okay, not that nice. Center, 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 right? So why do I say that? I was first start with the one that is you are very familiar with. Do you all remember just now we talked about the bow tie?
Yeah.
Do you realize that this looks like a bow tie?
Yeah.
But this is a little bit different from bow tie. So a lot of students are being tricked. What do I mean by that? Means if this is 100, right? Because angle at center is 2 times, right? So it means that this person is 50. But do you remember the bow tie? The bow tie says that if that is 50, the other side should also be 50. But remember, when it comes to bow tie, remember the bow tie one, the angles in the same segment? I told you guys that it must all be on the circumference. But right now, do you notice? One is on the center, another person is on the circumference. So this is when you know, oh, I need to use this property. The more you see one at center, one at circumference, you know for sure you're going to use this property. So far, so good? Clear? Now, the next shape you can remember. So this is called a bow tie, but one of the bow tie is stuck at the center. Clear? The next technique you should know is called the arrowhead. What do I mean by the arrowhead? You know it's arrowhead, right? You know there's this plant called the arrowhead. It looks something like that, correct?
Oh, yeah.
Oh, very ugly, but you'll get it should be one straight line.
It looks like a navigation thing.
So ugly.
I didn't say navigation.
Okay. Is it better?
Yes.
Oh, wow.
Yeah, better. All right. So it means that right now, if let's say here, whoa, here is 100. That means that here is it's not 100, but here is 50. Understand so far? And do you notice the location is center and circumference. And the tricky thing is, guys, look here. Can you see they start and end at the same point? The start and end are both at the same point. Can you see that? The red color one. Now, the next one I'm going to teach you guys is very tricky. If you haven't been listening, please listen. Super important. Okay? This is the tricky one. Because why? A lot of students, right, they get it wrong because they thought it's a cyclic chord. Remember the cyclic quadrilateral, the angles in opposite segment? The 4-sided, remember? Just now I told you guys. 1, 2, 3, 4. But remember the 1, 2, 3, 4, they are all on where? To use just now that one. It's all on circumference and the opposite is 180, correct? However, this one person is not. This person is on center, but this person is on circumference, circumference, circumference. Now, this technique, listen very carefully, and please don't go school and tell your teacher the strategy and technique because the teacher said it's fundamentally not right. Okay, but I'm just teaching you so that you're able to identify it properly. Usually we'll do smiley face with smiley face, sad face with sad face. What does that mean? So right now, who is the most important one? Always remember, okay, see this quadrilateral one? The one at the circumference is the one who determined this strategy. I repeat again. Happy face strategy, and sad face with sad face strategy. It's determined from here. So you start from here. So do you notice when it is at this, right? This is the angle, correct? Is it a happy face or sad face? Then let's put the eyes at that. Do you realize it's sad face? So a lot of students identify wrongly. They say that, oh, Miss Lin, this is the angle. Means if this one is like 50, this is 100. Wrong. Understand? Another thing that students make is they'll say that, what would they say? Let me redraw again. So why do they do it wrong? Students who are wrong is that this is a circle. This is my center. They will say that, oh, if this is 50, means this is 50 times 2, which is 100. They are wrong. Another mistake that students make is number 2. They think that it's a cyclic chord. Means they think that, just now the angles in the opposite segment, they'll say that, oh, if this is 50, that means that this person will be 180 minus 50, which is 130. Unfortunately, they are wrong also. And this is a common mistake made by a lot of students. This answer wrong, this answer wrong. Why? Remember the strategy that I tell you just now? If this is, remember, from the circumference is what you determine. This is set face, right? So should we be looking at this or should we be looking at this? Which one should we be looking at?
The outside one.
Yes, it's the outside one. So this is set face, means you must go with set face. Clear? So let's say this person is 50 degrees. That means that this person is 100 degrees. And how to find this angle here? So this is number 1. This is number 1. Then number 2, we can find, because it's times 2, right? And then number 3, from here, we take 360 minus 100, and the answer is 260. So can you see? It's not the same, huh?
Don't you have to like put the reasoning for 360?
Yes, later, but this one we are talking about the properties first. So do you realize? Student 1 say 100, pa. Student say is 130, pa. Also wrong. The answer is, this is the proper way to do. Understand so far? So that's why in the exam, teacher like to come out this one. Because a lot of students thought is angles in opposite segment. Wrong. Students thought is times 2 like that. Identify the wrong one. Also wrong. So you clear so far? So this one is what a lot of seniors and a lot of students make mistake in. But of course, you guys will not make this mistake because we already went through that. So later when you make notes, be extra careful, make more notes on this, and remember to color code. All right. So the last one that students make mistake is this. Here, they do not know what to do with this. Okay, it looks like a flag, right? Very ugly. Let me draw properly. Okay, see here? It looks like a flag. So how do we identify? So for the flag, right? Can you see this thingy here? If let's say this is 50 degrees, right? How do we find out? Dun, dun. Did I draw it wrongly? Oh, sorry. Here. Here. If let's say this is 50 degrees, do you all remember the same thing, the one in red? Just now I forget to identify. This is the one in red. The one in red, the one in red, okay? But this one is special case. So remember I told you it's a start and an end. Start and end, right? And here touches the center, and here touches the circumference, correct or not? So if here, can you see from here to here? Bam, bam. Here is 50, right? So it means that from here, bam, bam. That means that this person here will be how much? Can you see smiley face with smiley face? Because it's curved this way, smiley face with smiley face. With this 50 means this person must be 100 degrees. Understand? Now you can make your notes. Okay, so right now let's move on to number 6. Then later we're going to go to like angles and area and perimeter, okay, and sector and segment. And then I've cleared 2 topics already. 2 chapters. Done. And we finish the syllabus.
Yay! Revision. Exam paper.
All right, so right now it's number 6. Number 6 is more useful for emath. You can also use for emath, but you need to put the reasoning. So what is number 6? The reasoning is angles in alternate segment. Okay, it's called alternate segment theorem. Now, how to use this? Wherever you use this, right, is that you need to use a triangle technique. What do I mean by triangle? Can you see one triangle? All right. So to use this alternate segment is you need to have number one, a triangle. And all 3 points are on the where?
Circumference.
Yes, by now you all should know location matters already, yeah? Are all on the circumference. Next, number two, you need to know is this thing called tangent. So it's like a TT, okay? So what is tangent? Tangent is here. Tangent means, remember I told you all, just nice touching the circle at one point, correct? So far, so good?
Yeah.
So how to use it is first to identify. Can you see that this side of the triangle is touching the tangent? Identify that first, number one. Next, number two, is there's a reason why it's called alternate. So this is number two, right? That we're going to identify. So number two, to identify it means this is also the same. And number three, we identify the third side of the triangle. And this is number three. So far, so good? And can you see it's touching the line? It's not the part of the circle. It's not from here to here. It's from here to here. Understand the difference? Okay, and that's alternate segment. I'll not go too in-depth in that. We'll go more in-depth in emath. For now, just remember this. We'll go through again this in set 4. You'll see more of this.
Okay.
All right. You all can start making your notes. Number 6. Then we're going to move on to the next part, which is called the length properties. And then after that, we'll go for a break. After break, we'll do the area and perimeter in Secret 7. So just now, all 6 were angles, right? Right now, what we're going to learn is we're going to learn length. Then later, after break, we'll learn an area and perimeter. That's all. And we finished 2 chapters. We just need to practice already. Emath is so easy. It's like, oh. Right? Like crash course.
It's so easy.
Teach you all a little bit, 2 chapters done.
Wow.
Doesn't need a lot of practice.
So easy.
And we finished the whole syllabus. Now it's only June.
Yeah. Yeah.
Very scary.
What is scary?
Nothing is this easy.
Easy.
I don't trust that it will be this easy.
For emath,
Yeah.
it's really this easy.
I think the problem
There's no way you
with
can fail.
emath was
If you are
overthinking.
hardworking and just do a lot of practice and do the questions I selected for you all, like 1 month before exam, you're like, I don't even study, I also can do well. Like, okay.
Too complacent. Yeah.
Oh yeah, correct. That's why some students didn't do well.
Yeah.
Okay, let's continue. So the next one is, okay, the next property is called chords. You know what's chords already, right?
Yeah.
What are chords?
Bang on.
Yeah, her bangs. So chords. So I draw one bang here. And maybe like a goatee. Goatee. Bangs.
I don't think goatee got like 3 strands on it.
Okay.
Okay.
All right. Don't ruin your moments. Okay. So right now this is called chords equidistance from center. This is another property you need to remember. So this is a center, this is a chord, and this is a chord, right? So why they say equidistance? Equidistance means equal distance. Means here to here is equal distance. Understand? So when they are equal distance, what does it mean? Do you remember radius? This is called a radius from here to here. And this is called a radius, tiny line, tiny line. Radius, tiny line, tiny line. Correct? So if this is equidistance, meaning to say that the length of here, the length of here and here will be the same length. The one in red and red, okay? Same length, right? And if these two is the same length, I can now say that this chord and this chord have the same length also. That's all. That's it. Very easy. Okay. Next up, this is something we learned in emath. You're going to use a lot of it. So what is this? So this thing is same thing, the chord. Do you remember I told you about the three best friends? This is the center.
Center chord.
Chord. Right? So center and chord has this thing called the perpendicular bisector. The perpendicular bisector will cut through the center. This is called perpendicular bisector. So the reasoning that you need to memorize is called, hello. Okay. This is called perpendicular bisector of chord. Okay, so what does that mean? Perpendicular bisector of chord has two things. It means that number one, it will give you a 90 degrees right here. Number two, you know that here and here are same length. So far, so good? That's it. And number three, you know that it will cut through the center. So that is number two. So we have number one right here, number two right here. So far, so good?
Yeah.
You're like, huh, Miss Lee, so easy. Wait till you start doing the practices. Okay, number three is what we're going to learn. Number three, the last one, is also what we learned in emath. I'm going to give you a refresher. Can you see here? Can you see here?
Oh, this one. It's okay, just need to get.
No. Okay, so right now we will start from here.
Okay, no.
All right.
Okay.
Let's go.
Yeah.
Oh, the pigeon.
So right now, this is the center, correct? So remember, center to tangent. Who is a good friend of tangent?
Radius.
Yes. Radius and tangent always go hand in hand. This is tangent 1, so let's call it tangent 1.
T1. Terminal 1.
And this is tangent 2. And they have good friend that is called radius 1 and radius 2, which is the same radius. Remember I told you all, whenever it's radius, you draw tiny line, tiny line. And what's the relationship between radius and tangent?
90 degrees.
90 degrees, 90 degrees, right? So why do I say this? Because this thingy here, this person right here is called an external point. So yes, with the tangent meet, you're almost there with the property. So with the tangent meet, I'll draw this invisible line, which is called the orange line. Now, why is this so important? Can you see that they share the same orange line? And this is the same, the two pink one. That means that I can see that this and this will have the same length. That means that, I repeat again, number one, they share the same length. And because we know that this length and this length is the same, so I can actually say that this and this are the same. So technically, this property also helps us to tell us that there are actually two congruent triangles. You know it's two congruent triangles, right? Exactly the same. Meaning this angle here and this angle are the same. And this angle here and this angle here are the same. Draw double line. Yes.
Yeah.
Got it? So what does that mean and what property is this? Let me color it. Purple, purple, purple. Can you see the purple?
Okay.
And then after that, brown, brown. Okay. And what is this property? Number 3. Property number 3 that you need to remember. Property number 3, let me draw the line. Draw. Okay. So property number 3, this is called tangent from external point. Got it? The end, and congrats, with that we're done with 1 chapter.